Everyone, welcome back. So this is the continuation of where we stopped. In the previous lesson, we talked about opportunity. How do you identify opportunity in a system as an agentic AI product manager? And then we define a different opportunity, and then how you mitigate them, how you put them into consideration when you are designing agentic AI system. So now let's look at how you can balance quick wins with long-term advantage. How can you take long-term advantage of agentic AI system as a product manager? How can you present the long-term advantage of the product to the user, or to maybe B2B or B2C? How can you present the long-term advantage of the application that you are designing, that you are managing, to the end user? So the first one is quick wins. So identify your quick wins, low risk experiment that build internal confidence. So we have said that you should deploy gradually, iteratively, using agile methodology. So when you deploy MVP and you collect users' feedback and you use the feedback to improve the model, gather your quick wins. Okay, we have said before that you should collect failure feedback, and then use it to improve the system. So you can also gather wins, gather the successes, okay, and the experiment, and use those to build confidence. Do not only collect failure feedback, also collect success feedback and use it as a testimony to advertise the product, or to, or evangelize the product, let's say. So defense modes, long-term investment in proprietary dataset and knowledge graph. So make sure you implement defense modes, protect the data, and then make sure you have what we call an historical database in the warehouse. Azure database now supports even vector database. We have a vector database in PostgreSQL. We have in Azure Cosmos DB, or you can use the former method, Azure AI Search, to implement your vector database. So make sure you keep your historical data, and then you properly structure them, embed them, chunk and embed and index in a vector database, so that they can act as a defensive, platform for your agent. It prevents agent from hallucinating. It prevents agent from coming short of information about the company. Then we have phased approach. Use bounded agents for repetitive tasks before tackling autonomous strategic reasoning. So we have said that when you have a problem, when you get the pain point from the business users, the first thing you should do is to analyze and plan before you start designing. So identify what ordinary workflow can solve. If the problem is what workflow can take care of, use workflow instead of developing agentic AI system. If the problem can be solved by only a single agent, design a single agent instead of going for multi-agent. Because as you enlarge the capability of a product, the money you are spending, the budget also expand with it, and the maintenance, everything also expand. So use phase approach, use iterative method, deploy gradually. Deploy one agent, two agent, three agent, until you deploy everything by, deploying gradually, making the user use it, and then collecting feedback, and then using the feedback to improve the system. And then if they are good feedback, you also use it to boost confidence in the product. All right, so another point here is that you should choose the discovery approach for CADABA. I told you that CADABA is the cognitive architecture for deploying any agent. It acts as a vertical layer for deploying many agents, and a company can just have one cognitive architecture and build many agents on it, just like we have in LangGraph, or LangChain, and Llama Index. Okay. So choosing discovery approach for agentic AI architecture, the first one you should consider is ready, ape, and fire. Determine if the company is ready, determine if the users are ready. Then when they are ready, you should aim to design the application, aim to design the agentic AI. So even if the organization is ready and you as a product manager, you are not ready to design the product, you are not ready to own or manage the product, nobody will design it. So you should take a responsibility of aiming to design the product, And then when you aim and then you gather all your layers, all the required layers, architecture layer, infrastructure layer, you have gotten the design, everything, database and everything in place. The next thing is fire. Begin development. Get the software engineer, architect to start working at delivering the product to the end user. So for high risk, expensive or regulated projects requiring strict planning. So this is very, very important. You must make sure that you are ready to own the product, you are ready to design the product, and you are ready to see the product uh, to follow the product until it come out, and then not just come out, it come out successful, mature, and being used by the end users. Then another approach is ready, fire, aim. You can see it being shuffled here. So ready, it means that you are ready to manage, ready to design, ready to take ownership for low-cost prototype where rapid experimentation is the fastest way of learning. So make sure you are ready, then fire, aim. That is here. You ensure that the organization is ready to for the product, and then you start the design and development of the product, and then you aim to deliver the product. So that's this system ensure that you can after you determine that the organization is ready, you can just develop the product, even though they are not aiming at using it. You can develop it and keep it, and then you start talking to people about the product. So when they now everyone agree to adopt it, you can now or deploy it. Then we have the hybrid model, fast prototyping of UI with strict governance, modeling for the intelligence layer. So we have the hybrid prototype. You can use online and on-prem. You can use on-prem and cloud development. If it is a larger platform, like most organizations use hybrid development, they keep some of their data that should not cross border on site, and then those that can cross border, they develop it, they deploy it on the cloud using Azure cloud or other cloud. So I always use Azure cloud because that is my primary cloud. Okay. So fast prototyping of UI with strict governance, modeling for intelligence layer. So these are how you can, the approach you can take for choosing your CADABA architecture: ready, aim, fire, ready, fire, aim, and hybrid model. Then the next point we have here is the agent opportunity registry. So agent opportunity registry, under this place, how do you determine the, or what this place is currently look at is how do you determine whether, you've identified the opportunity, yes, but how do you determine the framework for managing the opportunity? How do you determine the framework for implementing the opportunity? So that's what we have here. You've identified that the company need the agent. You know that, okay, gather all the layers required, and the governance and everything ready. Then which framework do you want to use for it? So that is under the agent or opportunity registry. The first one is business process. So the specific workflow targeted. So that is why as a product manager, we say you should work with the business domain expert. There's what we call process intelligence in business, where where you have process mining and process management combined together. That is process intelligence. Under process intelligence, you have under process mining, you have data generation, data management, and business analytics, and business analytics and intelligent implementation to drive value for the business, to optimize the business. And then you have the process management. So these are just like the business managers, the general manager, procurement manager, finance manager, IT manager, they belong to those category. So when you combine process mining and process intelligence together, you have what we call the business process management. So as a product manager, you have to work, you have to have the knowledge of business process management. That's why you will say you are jack of all trade. You have the domain knowledge. You've communicated with the domain expert. You have the domain knowledge. We are not saying that you should be a practitioner in all this domain, but at least you should have little knowledge that will help you to be able to manage and deliver a product that is meant for that particular domain. So that is what we mean by, being a jack of all trades here. You don't necessarily have to be an expert in every field. Of course, we can't be an expert in everything. We are human beings. Okay. So business process. So the specific workflow targeted. Know the domain, know every domain in the company you are working for. Okay. IT domain. IT is a domain. Under IT, we still have subdomain. Say, we have the HR domain. So HR are the human resources and everything. We have the finance domain, which handle financial operation and accounting. We have the procurement and supply chain domain. Those handle contracts and supplier, their registration, payment, and everything. And then we have many other domain, guys, many other domain. We have the production domain, manufacturing domain, and many other domain in businesses, particularly in larger enterprise. So have domain understanding. When you are working with a particular domain, know their processes, know their data, know their platform, know what they do, by gathering information from them. So this information will help you to be able to design or manage a product that can solve their problem. Okay. Number two, expect value. So measure your return on investment and or outcome. So you are not designing for failure. You are designing for value. You are designing for profit. You are designing to make the work of people easy. You are designing for optimization, to optimize the business process. Okay. So expect value, expect the best, expect to add value to the department, expect to add value to the business, expect to have a return on investment, not just design a problem is solving people problem, oh, it's reducing their time, but is it accumulative cost, is it cutting cost, is it improving process, is it generating return on investment for the company? So you should also expect value. Okay. When you are managing a product, expect the product to generate value for the people using it, for the business organization that owns it. Okay. So required tools, we have the APIs, database, documents needed. So when you work with business process managers and then you gathered all their pain points, knowledge of the business and everything that should be done, and then you've put one or two things together, you've identified what can solve their problem. Maybe it is a workflow, maybe it is an AI or machine learning or an agentic AI. The next thing is to gather required tools. Okay. So it is you that will gather the tool and take the product, business problem, everything. You are the one that will take it to the architect. The architect will then design the architecture and hand over the architecture to the developers. The developers will now be the one to develop the backend and front end, and the DevOps teams, that's operation and delivery, software delivery team. After the quality assurance have tested the product, software delivery team will then deliver the product and to the end user, and then they use it, and then you go again to gather feedback. You can see that the process is iterative. You don't say, okay, because the product has been deployed, users are using it, you just go and sit down, you are done. No, you will still work with the user to gather feedback. Is it satisfying their need? Is it meeting their standard? Is it solving the problem that they expect it to solve? Is it adding value to the department, to the domain, or is it optimizing the business process and generating value? So you still have to determine all these things. Okay. So require tools. So for an agentic AI system, to build an agentic AI system, there should be some required tools that you should put in place. Okay. For example, you need API. Okay, you need API. Maybe they want to use fast API, which is the popular one, very good for agentic AI, or Node.js, for instance. You need a database, you need a RAG database, you need a relational database, you need a document database. So you can use, for document, you can use Azure Cosmos DB. For RAG database, you can use Azure AI Search or Azure SQL database. Or for RAG database, you can also use there's a domain in Azure Cosmos DB that can also be used for RAG, and then you can also use PostgreSQL or PG Factor for RAG. PG Factor for RAG, and PostgreSQL as the main database. So PostgreSQL and pgvector is always even considered to be to be friendly in terms of cost. It doesn't generate cost like Azure AI Search, Azure Cosmos DB. So you can decide to use those platform. Okay, there. All right. So hope everyone is following. So let me check my laptop whether it's charging. Sorry, I needed to check whether it is charging. So it's charging now. Let's move on. Yeah. So, my people, that's what I'm telling you about. So, as a product manager, you are supposed to be the one to gather these required tools. To gather these required tools, you can work with software engineers and software architects. Okay, so you will always have an IT architect or software engineer that know the tool to use. So you gather the tools and bring them together. APIs, RAG database, database, um you know Azure. Let me talk in terms of Azure. So for RAG database, Azure AI Search, PostgreSQL pgvector, or Azure Cosmos DB for RAG database. Then for normal database, you can use Azure SQL database or PostgreSQL database. Then for document DB, that is for unstructured data, you can use Azure Cosmos DB or blob storage, and so on and so forth. So this is what you can use. And for queue storage, you can use Azure Queue for that. And table storage, key value storage, you can use Azure Table Storage, and so on and so forth. So determine the database, determine the tools, what language. Is it Python? Is it C Sharp? Or is it Java? Or is it what stack are you using? Is it main stack or min stack? All these things has to be put into consideration. What will be used for the front end? Is it React? Is it TypeScript, or and so on, or Angular, and so on and so forth? So you should determine all of this beforehand. Then autonomy level. After gathering the required tools, you must determine the autonomy level. So for autonomy level, software engineer are not the one that will determine this for you. So for autonomy level, you have to work with security team and the business domain experts. Okay, yeah, not the software engineer, because software engineer are not the one that will use the product. So they may say, okay, 100%, where it requires just 70% or 80%. So to determine autonomy level of an agentic AI system, go back to the business domain expert. Uh, know the task that they would like the agent to take autonomy of 100%, and then use that to work with the security team, the governance team, or the AI Center of Excellence, and then know what the agent can access, know the policy guiding deployment of agent, know the level of autonomy that is allowed to be given to, that is allowed for agents to have in the organization. So for this, you will use organization policy and governance documents. So all policy and governance document will be used to determine the autonomy level. For example, in finance, or let's say in supply chain, for instance, if a supplier is, you know, generating a payment that is more than $50,000, you can say any payment that is more than $50,000 should be handed over to human to approve. Agent should not approve that. So that is a level of autonomy. So level of autonomy, it can be defined by using percentage, where financial things are not in, where money is not involved. You can use 70%, you can give 80%, and for or tasks that require less governance, you can give 100%. So when you define this, then anything that involves financial situation, you should define a threshold. Maybe anything above $50,000 should be handed over to human to approve or to take over, or to some kind of document approval should be handed over to the legal team or human in the loop that is acting as a legal person to approve instead of the agent approving it. So that those are autonomy level that you should put into consideration. So this is how you can solve the problem of agent opportunity registry and framework, business process, expected value, required tools, autonomy level. Okay. So the next point we have here is automate frequent workflows. So you should automate frequent workflow. Just as I would always say repeatedly, it is not all tasks that you need to use agent for. There are some simple tasks that simple workflow like Power Automate, Power App, or Logic App can automate. So why developing agent for, why going complex when simple workflow can actually do this? Then also there are custom agents like in Dynamic 365, we have the we have finance agent that is already built there. We have a HR agent, a CRM agent that is already built there. So if all these built-in agents in Dynamics 365 can solve your problem, then you don't need to build a custom agent. Okay, so you know, to build a custom agent, if it is not that complex, you can use Azure Copilot. You can use Copilot for it, Copilot Studio. But if it is very complex, then you have to take it to Azure AI Foundry to build it. So automate frequent workflows, not isolated decision. So the first thing you should do is focus on volume. Okay, AI provide the most value when handling thousands of small tasks. So focus on volume. How heavy is the task? Is it what a workflow can handle? Or is it what a single agent can handle? Is it what two agents can handle? So consider the volume of the task, how heavy the task is. The second thing you should consider is the process over task. Don't just automate a single prompt, automate the entire sequence from ingestion to reconciliation. So you don't need to automate just one prompt. No, the entire sequence must be automated. So, or let's say one agent carries one prompt and then you only automate that, leaving all other ones alone. No, everything should be automated. So, and then you cannot combine every task into one agent. Every agent must be assigned to a task, just like you cannot have a data engineer acting as, a supply chain analyst in another department. No, it's not possible. They have different tasks. So that kind of thing. So even in data engineer, you still have sub agent, like you have ingestion agent, you have a transformation agent, you have the data loading agent, you have the quality data quality agent, you have the analytic agent that will analyze, you have the visualization agent that will visualize, you still have the uh document agent that will generate visuals in form of document and everything. Then you have the recommendation agent that will generate predictive recommendation based on what the visuals generated and everything. And then you have a report agent that will send the report to the end users and everything. So you can see that even to develop an agent for data engineer, you have to combine like 10 tasks, making 10 agents. So also we have consider process over task, business process. For example, if you want to deploy for a data engineer, understand the process of a data engineer, okay? Not just the entire task of a data engineer. You know, data engineer follow processes. The first thing is to identify sources of the data. Then next, you ingest the data, then you transform the data, you check quality of the data, and then you load the data into warehouse, and then you analyze the data and govern the data, and then generate reports, recommendation, and then send reports to the managers. So you can see that it is entire process. But if you are looking at it as a data engineer as a task, you will not understand the complexity of the process. Okay, so it is very, very important that you understand business processes. If you are working with procurement, understand procurement process, know the beginning of their work to the end of their work, know the A to Z of their activities, what they do, how they do it, what processes they follow. For example, you have uh, purchase order. They identify whether there's a contract, then they generate purchase order, then they award contract, and then payment follows, and then everything follows. So those are like example of processes. So prefer understanding process over task. Even though you have just the understanding of the task, still prefer to break the task into its sub processes. So this will help you help you to know the number of agents or the number of workflows or the number of workflow or activity to combine together to solve the problem. So identify the processes, know the task, break process down into tasks. Bounded domains. So success is more likely in narrow, well-defined business areas. Okay. So there's what we call bounded context in domain-driven design. So bounded context says that every business domain must be bounded. That is, business domain application must not interact with another business domain application. And even if they want to interact at all, they should interact through a contract. So there should be a contract that will link them together before they have to interact. And I have been telling you continuously, autonomy must be bounded. The fact that agentic AI are autonomous, they are independent, they can act independently under any circumstances. That doesn't mean that they should have access to everything in the enterprise. That doesn't mean they should communicate illegally. That doesn't mean they should break company protocol. Okay, they must operate within bounded context. They must operate within bounded business domain. Excuse me. Yeah, guys. So what I'm trying to say here is that bounded domains is very, very important in system design. So success is more likely in narrow, well-defined business areas. Okay. So, or develop for domain, not for the entire organization. You can't develop an application for the entire organization at once. No, develop for each domain. Then when all the application are now combined together, then you can implement microservices to bring them together as one application, but all domain must still exist as a microservice under their own operation, and their data must be bounded to them. So their data must not be exposed to another domain. So every domain must be bounded. So agents should also be bounded to a domain. Agents should be limited to their domain expertise. So do not allow a procurement agent to access human resources that database. Okay. Do not allow an IT operation agent to access finance database because it doesn't have business there. They must operate within their boundary using the company's policy and governance. So these are ways that you can, these are things that you should consider whether you should implement just workflow or isolated decision. Focus on volume of the task, break tasks into process, not just the entire task, and operate, make sure the application is bounded to the domain. Okay. So the next thing we have here is measuring defensibility through data loops. So defense in depth. So is a language in cybersecurity. So defense means defense is actually prevention. We have defense, and then we have defensive security. We have offensive security. So offensive security is just like intentionally exposing the application to threats, and defensive security is defending the application from being exposed to threats. So that is just what they mean here. So how can you protect data loops? How can you protect data application, access control, release privilege? How can you protect the application layer of any company database from being too exposed to the agent or from being exposed to risk because the agent want to access it? So the first thing you should consider here is proprietary data. So train model on internal logs that competitors don't have. Okay. So of course, I've said that the first thing is to, when you are designing a product, is to consider your competitive strategy, your competitors. Identify your competitors, identify what they are doing and what they are not doing well, their weaknesses. Then you can now use their weakness to improve your own product so that your product will be more unique than theirs. Okay. So to do this, have a proprietary data. Use specific log that your competitors do not have. Use a database that your competitors do not have. Use their weakness against them to improve your own products. That is what I mean. Feedback flywheel. As user correct the agent, the system become more accurate, creating a better product. So use feedback flywheel. Okay, implement feedback. For bad feedback, use it to improve the system. For good feedback, use it as your testimony to advertise the product. Okay. Network effect. More agents in CADABA architecture, share learning, increasing total organization intelligence. So networking. So in this CADABA architecture, I have said that it is a vertical platform that you can just deploy for a company and then start deploying agents on it. So the agent will eventually communicate through networking. So network will in we make them interact together. So make sure you also operate within a bounded network so that the agent will not be exposed to each other. So agents should share learning, increasing total organization intelligence where necessary. And when they are doing that, they should do that through what we call contracts. So by awarding contracts. So agent A can communicate with agent B through a contract that is still within the bounded context of the domain that they are operating in. So the next thing we have is technology assistance on a scale of forms. So technology assistance assist on a scale of forms. Okay, so we said, there are different technology end goals. Okay, so your goal. So the goal of one domain may be different from the goal of another domain. So the intelligence of a particular domain is different from the intelligence of another domain, even though they are within the same company or enterprise. Okay. So like for example, the visuals you will build for procurement procurement intelligence, it's not the same visuals that you will build for IT operation intelligence, because they are if even though the data may look alike, they are communicating different meaning. Okay, different meaning and different context. So when you are designing have intelligence on a scale of forms. For example, predictive AI. You can design a predictive AI to identify pattern and forecasting, like demand forecasting and supply chain. We have generative AI. So you can develop a generative AI to produce new content or summarizing reports, drafting and sending to people's email. Then you can develop agentic AI, which is autonomous AI. Planning, it can plan, take action through external tools like auto approving invoices. And then you can use CADABA Go, which is a multi-agent architecture which go beyond just an agentic AI into multi-agent platform that can consist of 10 agent, 50 agent, 100 agent, or swarms of agents. So using all three in concert to solve complex business problems, identify the need of the business. We have said it that you don't just start developing agent. Identify if a simple workflow can surface or can satisfy the business problem and solve the problem without complexity. So in domain driven design, we have said that you should design for complexity. So if the system is complex, design for the complexity. If the system is simple, design for simplicity. So also in the agentic system, design based on the complexity of the business domain or of the intelligence or of the um problem the domain want to solve. If predictive AI is enough, then deploy a predictive AI by building on a machine learning model. Then if generative AI is enough to solve the problem, then deploy a generative AI by using a base model, prompts, and the RAG database and fine tuning, and then you deploy. Then if it is an agentic AI problem, then you use agentic AI and limit to one agent if you can solve the problem. Then if one agent is not enough, then you move to multi-agent system, deploying two or more agents on a CADABA architecture or a multi-agent system architecture with orchestration layer. So this is how you can measure intelligence on a scale of forms. So next thing we have here is data modalities. So data modalities define process techniques. So what are the data modalities that you should design or take care of under process intelligence? The first one is test and code. So the primary language for API reasoning and API calls, what language they use? They use SQL or DAX or Python query, pandas or C sharp or Node.js or anything. What language do you want to use to design the backend and communicate with the database? Then the next thing is to determine numerical data. This is very, very crucial for analytics. Okay, so in data engineering, we have what we call the data modeling, where you model data into fact and dimension table. Fact table holds key metrics and KPI of the business, while dimension table or description of all those metrics and KPI of the business. So numerical data is crucial for predictive modeling and financial agent. So it's very, very important that you determine the data model, know whether they are, just descriptive data or numerical data. Then also know the type of data. Are they images, are they audio, or are they files? So expanding agent into visual inspection and voice-based service. So also consider when the data modalities. The first one is test and code. So use test data, document data, even data from code, then use numerical data, and then use image and video, so that if you want to build an agentic system that should be able to generate a report using video or using images or using narration, then you need to involve a data that have images and audio. So expanding agent into visual inspection and voice-based service. And then you can also use multimodal system by combining this to build a holistic understanding of a business event. So multi-modal system use many database, many sources: SharePoint, OneDrive, Cosmos DB, Azure Data Lake, Data Warehouse, RAG database, internet, web, and everywhere that data is accessible will be connected to the system. So these are form of data modalities that you can have. So the next point here is adopting a neuro-symbolic architecture. So neurosymbolic architecture is what enable agents to reason in loop, is what enable agents to think like a human being, it's what enable agents to be empathetic and to behave just like a human being. So combining deterministic rule with flexible neural intelligence. So neural intelligence builds on what is known as recursive intelligence, AIXI. So that's or AIXI. We have AIXI, which is artificial intelligence and explainability, and then we have artificial super intelligence, ASI. So artificial super intelligence is built on neurosymbolic intelligence, that is using, you know, or converting like human nervous system, modeling human nervous system into mathematics, then convert the mathematic formula into a symbolic algorithm, like convert the formula into code, translate neural system of a human being into a mathematical formula or a theorem or a lemma. Then you convert the theorem, you convert the formula into an algorithm, like Python algorithm and everything. Then you use it as a cognitive architecture for the agent. Then the agent begin to think, begin to bring things together, bring knowledge together, act on its own, passive, and he become reflexive on his own, taking decision, reasoning, and acting independent of a human being or any other platform. So that is why this is is a very, very strong architecture, very, very strong. So symbolic layer. So in neurosymbolic architecture, you have symbolic layer. hard-coded business rule and compliance limit that never change. You have the neural layer, which is LLM and predictive model that handle ambiguity and natural language. And then you have the integration layer, which is a neural agent that plan the symbolic guardrail, enforce the budget. So you can see that recently, uh, Azure OpenAI GPT was said to have broken into one of large chain platform to access the database by breaking into their guardrail. And when they discover it, they were testing the AI on something, and then it was just finding its way, acting on its own, to just achieve, to just do the work. When you force an AI to do something, to just give you the best, put all its knowledge together and give you the best, the agent too will want to deliver the best that you have assured it to, that you have told it to deliver. For example, you have a child and then you send the child to school, and then you tell the child that, see, this school that I've sent you to, you must not come home with any certificate or report that is less than maybe first or second. So the child will try, maybe the capability of the child is at maybe position 10, and then you want the child to have first position. So the child will have enemies. So this is why some children in school, they cheat. Why? Because their parents have given them a bounded contest. You are bounded to coming home with first position, and the child that doesn't have the capability of coming home with first position, we just find all means, maybe to carry an expo, or to look at the other student sheet, to in order to cheat from them, or to look for any means, whether cheating in examination. It will just look for any means to achieve that first position, because you are giving it that condition. So also, if you give an agent condition, it will want to just achieve that goal using everything on its capability. And when you are using neurosymbolic architecture, the agent can break out of its boundary just to achieve that goal that you have given to it. So that is what we have for this architecture. It is a very, very, very strong architecture, and my CADABA framework is actually built on this neurosymbolic architecture. So you can adopt it. Visit our website for more of this thing, and if you like your company to adopt it, we can license and deploy it for you. Okay, it's one of my newest products, and it's very, very fantastic. So in neurosymbolic architecture, we have the symbolic layer where you have the hard-coded business rule and compliance limit. We have the neural layer, which is the LLM, together with recommender engine and predictive model, combined together in form of natural language understanding as well. And then you have the integration layer, which is where you implement guardrail and define what the agent must access and what it cannot access. So, all right. I think we should stop this slide. So we have looked at a lot of things. So when we come back, we'll continue with automation level from assisted to autonomous. Okay, see you guys. So if this is your first time of coming here, please kindly like and subscribe. Okay, guys. Encourage your girl, encourage your girl, encourage your girl. So encourage your girl so that I can do more video and also be able to generate income from this. Okay, so it won't cost you anything. Just encourage your girl by subscribing and liking this video, and sharing the video with other people that may need the video as a product manager. Thank you everyone for